to find square root of any number, whether the number is a perfect square or not. By arithmetical method, we can find the square root of that number. Though, if the number is a perfect square, we get natural root of integer. We are dealing with positive numbers and we take roots also as positive roots. So we get positive integral number as square root if the number given is a perfect square. Like 9, we will get 3, root of 16, we will get 4, root of 25, we will get 5, and so on. But if the number is not a perfect square, then also we can get its root approximately to some decimal values, though the decimal values that we get by arithmetical methods of getting square root are non-ending and non-recurring, thereby suggesting that the roots we get is not a rational root. It is an irrational number which cannot be expressed as the ratio of P upon Q, Q not equal to 0, like rational numbers that we know. The irrational roots cannot be expressed in decimal form. Suppose root of 10, we have to write square root 10 like that, but the decimal value of that square root is not ending, neither recurring. Now, there are some steps to be followed for the process. Step 1, mark the bars on every 2 digits from one's place, left side to the decimal or integers and on right side to the decimal or fractions. Like suppose we have 1275.78 is the given number. We are supposed to find out the root of this number. Now from decimal point, here is the ones digit, tens digit, hundreds digit, thousands digits, like that. So from decimal point, starting from one's place, you go on making parts of 2 digits, putting a bar. Ones and tens, hundreds and thousands, like that. And to the left of this decimal point, and if there are some fractional numbers toward the right of the decimal points, go on taking 2 digits to the right of the decimal point. Like here 78, and we can put as many zeros that won't change the value for the given number, take 2 parts ahead. If the number remains, if there remains 1 digit on the end, put 0 to make pairs. Suppose you are given 359.718. Then from decimal point, put bar over 2 digits, that is 59. There remains 1 digit only 3. Put 0 and make bar, or simply half bar. So this becomes the first pair, this becomes the second pair, this becomes the third pair, this becomes fourth pair, and if you go on pairing, we get one by one after the other the further pairs for further values of fractional points next to the decimal point. Step 2. Carry out division using the same number quotient, taking first highest place value bar segment, that digit of the dividend. Now let us consider, we want to find out the square root of 1275.78. Now we have divided this into segments from digit, decimal point 75 and 12. Take the highest segment. So we have to deal with this highest segment, which is 12 here. And if we take this will be 3 only. Now 12 is the first segment that we have to divide. Now go on dividing by taking divisor 1, 2, 3, 4, 5 like that. To get subtractible value by multiplying the divisor by itself. Suppose we have to carry out division by 1. So 1 was the 1. If we take 2, 2 to the 4. If we take 3, 3 is a 9. Like that. Multiply the divisor, taking the same number quotient, and get the part of the dividend. So if 4 for the 16 is not subtractable from 12, so division by 4 will not go ahead. So we take 3, 3 is a 9. Subtract 9 from 12 remains 3. And then carry down the whole next segment. Not one digit only like the normal division, but carry down the whole next segment of 2 digits, 75. And the quotient you add to the divisor, that is the step number 3. Add divisor and quotient. Here divisor is 3, quotient is 3. Add 3 to 3, that is 3 double it. Here 6, which becomes the part of the new divisor. Now, we have got 6 here. Carry down the next low, carry down the next, we have taken the next lower place value bar segment. 75, the bar segment place, bar segment next to 12, the lower value. Put 1 to 9. Here 6 we got. Next to 6 you put 1, 2, 3, 4 like that. And multiply this new divisor by the same number. If you put 1 here, multiply 61 by 1 and get the quotient and the part of the dividend. If you put 2 here, multiply 62 by 2, get the quotient 2 and subtractable part for the dividend. If you put 3 here, multiply 63 by 3 and put 3 here and get the part. You go on trying to get the highest subtractable value for the remaining 3 and next bar part 75. So taking 75 down, we get 375, the new dividend. And if we go on trying, we see that 5 is the number. When we put next to 6, becomes 65, and if we multiply 65 by 5, we get 325, the highest subtractable subtractable number from 375. By 6, the highest number becomes 6 in the 36, which would increase than 375 by complete multiplication by 6. If we put 6 here, 66 multiplied by 6 becomes larger than 375. The division will not go by 6. So the highest number subtractable is obtained by previous 5. So put 5 here and multiply 65 by 5. If you cross the decimal point, over here you put the decimal point after crossing the place. Put 5 here. 5, this 5. 65, 5 is a 325. Subtract 325 from 375, we get 40. Now, after 75, we have to cross the decimal point. So, over here also, cross the decimal point. Now, this 5 divided by 65, get 70. Now, 70 becomes the next part of divisor. See, divisor goes on changing every step. Next to divisor, you go on putting 1, 2, 3, 4, 5 like that, and get the highest number, which multiplying with the new divisor becomes highest subtractable number from the new dividend part. Now here also we see that 5 is the highest number when multiplied with 705 becomes 3525, the highest subtractable number from 4078. We have taken down 78 here, the next bar part. So by 5 the division will go and multiply the divisor by 5, we get 3525. Now remains, when we subtract this 3525 from 4078, we get 553. Now 553, the next, if you want to get the next digit, carry down these 2 zeros here. These 2 zeros to next to 553 and 2 zeros. Then add this 5 to 705. It becomes 710. The new part, next part of the new division. Now, if we go putting 1, 2, 3, 4, 5 here at one place of the new divisor, we get 7, the number, such that when multiplied with divisor to get the number which is the highest subtractable number from 55,300, and that is 7107. Put 7 here, carry down, put the quotient here 7, quotient digit, multiply 7107 by 7, we get 49,749. Subtract 49,749 from 55,300, we get 16,151, the remainder. And next, we can carry out these 2 zeros and carry on the process further. So, after 2 decimal value, the square root of 1275.75 is 35.57. So, we have the approximate square root value of 1275.78 is 35.57. 57 up to 2 decimal places. Now we can put as many zeros next to the last digit after the decimal point, which are not changing the value of the given number, and we can go on carrying down the division process to get one after the other decimal place values for the root. And these values are such that they are neither recurring nor ending, so that the decimal value of the root is an approximate value and not exact value. Thus, the decimal value of non-perfect square is irrational. Dear students, this is a very good method to calculate decimal values or square roots for the given number.